Today we are going to investigate a solution of this wave equation, and actually the solution is a part of the D'Alembert equation. For part A, we assume that you have this form where g is an arbitrary function which is twice differentiable. Well, that means that you can take the derivative of g twice, and lambda is a constant. And g here is a function of one variable only. And the questions ask you to calculate uxx and utt. And for this part B, suppose that you have this form. We have to find all the values of lambda such that u satisfies the equation start here. Let's start with part A. So first we need to understand the notation uxx and utt mean. So actually uxx is a short notation of the second partial derivative of u with respect to x. So it's a short, it can be written as this. And if you write step by step, it's a partial derivative with respect to x of the first partial derivative of u with respect to x. And since u is equal to g, we just replace the u here with g. So in order to calculate the second derivative of u with respect to x, first we need to calculate the derivative of g with respect to x. And here you can see that g depends on x minus t. So in order to calculate the things in the brackets here, we need to use the chain rules. So to use the chain rules, first we denote z equal to x minus lambda t. And then we can draw a diagram. So first we have a function g, and g depends on z, which is x minus lambda t. And here z depends on two variables, x and t. So x and t here are independent variables. That means that they don't depend on each other. So to use the chain rules, we need to find the derivative with respect to all the legs here. So for the legs from g to z, we have the derivative of g with respect to the derivative of g with respect to z. So we got dg over dz. For these legs, we have the partial derivative of z with respect to x. And for this second leg, similarly, we have the partial derivative of z with respect to t. So notice that here I use a different notation here. For these two legs, I use delta instead of d. So this delta means the partial derivative. For this one, I use dg over dz because g depends on only one variable, which is z. Now to calculate the thing in the bracket here, so it means to calculate the derivative of g with respect to x, we need to look for all the paths that go from g to x. So in this diagram, we have only one path, which is g go to z and z go to x. Therefore, using the chain rule, we have dg over dx equal to the dg over to dz times dz over dx. So we got that part times this part. And now, because z equal to x minus lambda t, we just replace the second part by d of x minus lambda t over d of x. So the derivative of x minus lambda t with respect to x is just equal to 1, because in this case you treat t as a constant. So that equal to dg over dz. So now we have the first partial derivative of g with respect to x. So we are ready to calculate the second derivative of g with respect to x. So first I just rewrite what I wrote here. So we got u xx equal to that. And because the derivative of g with respect to x, what we calculate here is equal to dg over dz. So all we need to do is just replace the thing in the bracket here with dg over dz. And here, similarly, we use the chain rules again. So it will be similar to this leg, but g will be dz over dz. So we got d over dz of dg over dz. And the second part, which is this leg. So for the first part, it can be written as this is that is second derivative of g with respect to z, and dz over dx again at this part, and it equals to 1. So term 1 and so for that is for u of double x. So similarly, we do u double t. So u double t equal to the second partial derivative of u with respect to t. And in this case, let's do it straightforward. So for the thing in the bracket here, we use the chain rules again. So we got this leg, we need to sum up all the part from g to t, and in this case we have only one part from g to z and z to t. So that would equal to so for the thing in the bracket, we can write as dg over dz times the partial derivative of z with respect to t, and that equal to and the partial derivative of x minus lambda t with respect to t is equal to minus lambda. So this one would be equal to minus lambda dg over dz. And because lambda is a constant, you can put that outside. So it's minus lambda d over dt dg over dz. And again, we will use the chain rules for this part. So we use a similar part, g to z and z to t. And that will equal to minus lambda d over dz of dg over dz times dz over dt. And again, the partial derivative of z with respect to t equal to minus lambda. So here it got minus lambda, and the first part, this part can be written as d squared of g over dz squared. And that then, and this part is minus lambda. And now we've got minus lambda times minus lambda. So we got lambda squared times the second derivative of g with respect to z. Okay, so now let's move on to part B. And so for part B, we need the formulas for the second derivative of e with respect to x, the second derivative with respect to t. So I just copy these formulas into this part. So now we need to find all the values of lambda such that U satisfies the equation stars here. So now, because we know that the second derivative of U with respect to x equal to this, and the second derivative of U with respect to t equal to this, all you need to do is substitute 1 and 2 into the equation star. So substitute 1 and 2 into star. And then we have, so we just simply replace the first part with lambda squared times the second derivative of g with respect to z. And the second one is 16 times the second derivative of g with respect to z. So now here we have the second derivative of g with respect to z as a common factor. So we can simplify this equation as lambda squared minus 16 times the second derivative of g with respect to z equal to 0. So in order to get this one equal to 0, either the first factor, lambda squared minus 16 equal to 0, or the second derivative of g with respect to z equal to 0. But because we don't want to put any restriction on g, so that means the first factor should be 0. So therefore we have lambda squared minus 16 equal to 0. And that implies that lambda equal to plus or minus 4. And that's all the values that we need. Thank you for watching.